Hello, everyone. Today, we are going to learn about the density of sandstone materials. Let's look at a real case. Number 1. Overpass Bridge Project of Funing Road Connecting Line Project in Nanning City. The design strength of precast hollow beam slab concrete is C50, and Class 2 crushed stones and Class 2 sand are required to be used. Crushed stones and sand shall be standard in terms of apparent density, bulk density, porosity, and other indexes. The contractor shall entrust the laboratory to carry out various index tests on crushed stones and sand and issue test reports. Do you think that the case is very professional and the terms are unfamiliar? Don't worry. Today, I'll figure out their meanings with you. What do Class 2 crushed stones and Class 2 sand in the case refer to? According to technical indicators, sandstone can be divided into Class 1, Class 2, and Class 3. Among them, Class 2 sandstone can be used in C30 to C60 concrete, and C30 represents the strength grades of concrete. We will further study it in subsequent courses. Next, we will learn about the physical constant of sandstone materials. 3 nouns related to density: apparent density, bulk density, and porosity. We all know that the density learned in secondary schools equals mass divided by volume. The density to be learned today defines different states of mass and volume. Different states lead to different densities. Next, let's learn about the volume composition of sandstone materials. Getting a good command of the density constant requires understanding the volume composition. From this picture, we can see that the total volume of sandstone materials in a bulk state includes the volume of particles themselves and the volume of voids between particles. The volume of particles includes solid volume, closed pore volume, and open pore volume. Therefore, the total volume of sandstone includes 4 parts: solid volume plus closed pore volume plus open pore volume plus void volume. Please notice the difference between pores and voids. Let's learn the apparent density first. It refers to the mass of unit apparent volume of materials under specified conditions. This condition refers to the state of drying in an oven at 105 plus or minus 5 degrees Celsius to constant weight. That is, dry state. The apparent volume includes mineral solid and closed pore volumes. The formula for apparent density ρA equals solid mass divided by solid volume plus closed pore volume. The unit of apparent density is gram per cubic centimeter or kilogram per cubic meter. You have to write down this formula. Then, how to determine the apparent density? The apparent density can be obtained by calculating the solid mass and apparent volume respectively. The solid mass ms is obtained by weighing the material with a balance after drying it, and the apparent volume is obtained by immersing the dry material in water and measuring the volume of discharged water after saturation. The determination methods include the basket method, wide mouth bottle method, and volumetric flask method. We will further explain these test methods in the following experiment classes. Next, let's learn about the bulk density. Bulk density refers to the mass per unit bulk volume of materials in a natural bulk state. What is the natural bulk state? Sunaba and sand piles are in a natural bulk state. We have already mentioned that the bulk volume includes the volume of particles and the void volume between particles. That is, the bulk volume consists of four parts: solid volume, plus closed pore volume, plus open pore volume, plus void volume. The formula for bulk density is the solid mass divided by the solid volume plus open pore volume plus closed pore volume plus void volume. The solid mass is the dry mass of the material, and the unit of bulk density is gram per cubic centimeter or kilogram per cubic meter. So, how to determine the bulk density? The bulk density can be obtained by calculating the solid mass and bulk volume respectively. The solid mass ms is obtained by weighing the material with a balance after drying it. The particle material is filled exactly to the top of the container, and the volume of the container is the bulk volume of the material. The current standard uses the volumetric lift method to measure bulk density. We will further explain these test methods in the following experiment classes. According to GB/T14684-2011, Sand for Construction and GB/T14685-2011, Crushed Stones and Pebble for Construction, the bulk density is divided into loose bulk density and packed bulk density according to different bulk states. The loose bulk density is measured by dropping the sample freely from above the volume cylinder. The packed bulk density is measured by padding the sample in layers. Let's learn the porosity. Porosity refers to the percentage of void volume among particle materials in bulk volume. The formula is 1 minus bulk density over apparent density times 100%. Porosity reflects the filling degree of sandstone materials and is an important index to measure the gradation of sandstone and an important parameter for ratio design. In this case, what values of apparent density, bulk density, and porosity are required for sandstone to meet the standard? According to the national standard GB/T14685-2011, Crushed Stones and Pebble for Construction, the apparent density of rubble and pebble shall not be less than 2,600 kilograms per cubic meter, and the porosity of Class II stone shall not be greater than 45%. According to the national standard GB/T14684-2011, Sand for Construction, the apparent density of sand shall not be less than 2,500 kilograms per cubic meter. The loose bulk density shall not be less than 1,400 kilograms per cubic meter, and the porosity of Class II sand shall not be greater than 44%. You should not deliberately memorize these values. You only need to know how to obtain data by consulting the standard. Summary 1. The focus of this lesson is to master the concepts and formulas of apparent density and bulk density, and note that the difference between them lies in volume composition. 2. Master the concept and formula of porosity. Please think about 1. What is the difference between porosity and void ratio? 2. For the same material, which is greater, the apparent density or the bulk density? That's all. Thank you.